Let's talk about another vocabulary term. We have a difference between a dilute versus concentrated solution. So let's start with a dilute solution. So a dilute solution is one that contains a low concentration. Basically, there is not very much solute compared to the overall size of the total solution. Okay? In the opposite way, we have a concentrated solution. A concentrated solution is one that is the exact opposite. It has a high concentration of solute. Okay? Basically, there is a large amount of solute compared to the total solution. Okay, so we can look at the pictures here. Okay, a dilute one doesn't have that many particles. We see that it has like 7 particles over here. In a concentrated one, you have a lot of particles. I'm not even going to count, but there's basically more than 7, so it's more concentrated than a dilute one. Okay, so then you can make a solution less concentrated by diluting it. How do you dilute something? You're going to add more solvent. And in this case, it's just going to be more water, right? Our water that is a universal solvent. If you measure the volume before and after, you can figure out the new molarity, the concentration of the new solution. So here you can see that there are 6 particles here. If you want to dilute it, you're going to add water to it, but you still notice that there are 6 particles. There's just more water now. And so we say that it has the same number of moles because it still has 6 particles, okay? But the concentration is going to change because we added water to it. So the volume changed, okay? So we're going to learn a new equation. It's M1V1 times N2V2. So let's sort of recap what each of these letters mean. M stands for molarity. This is another word for concentration. How concentrated is your solution? Okay, and V stands for volume. This can be in milliliters or liters because you can see that volume is on both sides of the equation. So as long as they match, okay, they have to match, then it doesn't matter because the units will cancel out. Remember 1s and 2s from gas laws. 1 is for your initial, right? This is what it started at. And 2 is final. Basically, what did it end at? It ended with these numbers. Okay, so now that we recapped your equation, let's apply it to some practice problems on the next page. Okay, so let's rewrite the equation up at the top. It's M1 times V1 equals M2 times V2. Okay, remember that our volumes can be milliliters or liters as long as they match. Okay, so now let's read problem number 1. It says how many milliliters, okay, it wants milliliters of a stock solution of half a molar sugar water would you need to make 150 of a 0.1 molar solution to feed your pet parrot. Okay, now it doesn't matter the 1s or 2s, what order they go in per se, but we do need to make sure that the numbers that are here, you have this number and this number and this number that you need to label them correctly, okay? When you see this of, okay, it links these 2 numbers together, okay? So you see this word of, it's going to link these 2 numbers together. So you can make them 1 or you can make them 2, but they must be the same number. So if we look here at this linked numbers here, we see that it's a molarity, so you can label this M1. If this is 1, then this milliliters, which is a volume, must be volume 1 as well. They must match because the word of links them together. Then over here, you have 0.5 molar, okay? So this could be your second molarity, okay? Say you were like reading this and you were labeling as you went. So I'm going to erase this and erase this and erase this, okay? So say you were like, oh, this is my molarity here. I'm going to label this M1. Okay, then this, because you see another M here, is M2. But because of the of, then this volume must be 2 as well because they must be linked together. Okay, so whichever number scheme you use, doesn't matter. But here I'm just going to leave it like this. And then I'm going to plug in everything that I know. Okay, so my first volume is something I don't know. So I have molarity 1, which is 0.5. So this was M1. I have a V1, and I need a M2, and I need a V2. Okay? I'm going to write this a little bit smaller so I can fit it. So I have 0.5. I don't know V1. That's this right here. I don't know this. Okay? It's equal to M2, which is 0.1, and my volume is 150. All right, so I want V1. This is like your X all by itself, so I have to move this to the other side. You ask, what is it doing now? It's multiplying, so the opposite is divide on both sides, and hopefully you get that the volume is 30 mils. If it has mils over here, it's got to match the units. All right. The next question asks, how much of a 4.5 molar solution of calcium hydroxide would you need to make 25 mils of a 0.6 molar solution? Okay. So we have several numbers here. We have a number here, here, and here. Okay, so let's identify them. Okay, here is my molarity, so I'm going to label this M1. Okay, here it's milliliters, so I know this is a volume. Here this is molar, so it's molarity. I have an of here, so I know these numbers are connected, so I have to give them the same number. I already used the number 1 on this side, so I'm going to make both of these the number 2. Okay, so now my equation, M1V1 equals M2V2. And let's plug in all my numbers. Okay, so I have 4.5 times V1 equals 0.6 times 25. Okay, once again, this is like my X, so I want this by itself, so I got to move this to the other side. You always do the opposite. It is multiplying right now, so you must divide. The volume then becomes 3.33 mils. It's mils because you must match it with the other volume. All right. Next question. This is like a 2-part question. Okay, so let's look at this very carefully. It says you have a 7 molar stock solution of sodium hydroxide. Calculate the amount of 7 molar stock solution needed to make a 200 mil of a 0.3 molar solution. Okay, so we have this number here, this number, and this number. Okay, so if you're paying attention here, it's connected by this of. So I know that these numbers are connected. I must give them the same number. So this is a volume. This is molarity. So I can give them both 1s. And here I have another molarity. So I can give this a 2. Okay. You can basically swap the numbers and it wouldn't matter as long as this side matches because it's connected with that of word. Okay. So let's do the math. We have M1 V1 equals M2 V2. Let's plug these numbers in. You have 0.3 times 200 equals 7 times V2. You want this by itself, so you're going to move the 7 over. So the volume then becomes 8.57 mils. Okay, so this is part 1. Okay, remember that the units must match. Okay. So now let's look at the second part of the question. It says, how much water would you need to add before you have 200 mils of 0.3 solution? Okay, so this is basically the second part of this problem up here. It's asking how much water we need to add to get to 200. So we're going to draw in these little beakers right here, or these graduated cylinders here, so that you can understand it. Basically, you got the answer 8.57 mils. So that means that we started, so if we color this in, we started with 8.57 mils in here. Okay. It tells us it ends with 200 mils. So this whole thing gets like filled up. Okay. It's going to get all filled up, 200 mils. The question is, I started with 8.57. I'm going to add what? Water. So water's here to get to 200 mils. So the question is, the big fat question is, how much water did I add to go from 8.57 to 200? So what kind of math are we doing? Good. We are actually doing subtraction. Okay, so we ended with 200, but I started with 8.57. So if I subtract, then I will get 191.43 mils of water added. Okay, so what is happening? We basically diluted the solution, right? We started with 7 molars. Okay, so follow my red pen here. We started with 7 molars and we diluted it to 0.3. Okay, so we added a bunch of water to make it less concentrated. We make it less concentrated by adding water to it. So you started with 8.57. If we added 191.43 mils of water, you get 200 mils of this concentrated 0.3 solution. Okay, so that's a 2-part question. Okay. The next problem here, it says you try is just like the problem above, but we put it into one question. It says how much water must be added, okay, if you have this number, and you dilute it down to 2.9. Okay, so I'm going to sort of set it up a little bit. So once again, it's connected by this of here, so you know that these numbers are connected. So this is V and this is M, so I'm going to give them the same number. And here is M2. Okay, I would pause here to make sure you can do this on your own, and then you can play it to get the final answer. I am going to write it all out, and it's going to just appear right in front of your eyes. All right, so here are the answers. You had to do 2 parts, okay? The first part was to find out your volume here, and then you ended with this volume, right? You started with this volume, and so if you subtract, then you know exactly how much water you added to go from start to end. All right, perfect. All right, this bottom part right here is trying to recap something that we talked about earlier. You know that the equation is molarity equals moles over liters, right? So if you sort of, it's supposed to be a very quick type of answer, but in case you can't see it very well, it says a 1 molar solution contains blank amount of solute per 1 liter of solution. So if you plug this in, it's like 1 equals moles over 1. So how many moles of solute do you have? You have 1 mole. Like for number 6, if you have 0.5 here, and you want to know the number of moles over 1 here, okay, then what divided by 1 gets you half? Right, it's going to be half a mole. Okay, for number 7, you think, okay, I have 1 molar. I want to know number of moles of 2 liters. What divided by 2 gets me 1? It's going to be 2 moles. Okay, you got to think that you're doing moles divided by liters, right? So moles divided by liters should get you molarity. So if you look up here, so 1 divided by 1 is 1. 0.5 divided by 1 is 0.5. 2 divided by 2 is 1. All right?